Leaving Cert Higher Level Paper 2 Question 2 in 2015 was a statistics question. A survey of 100 shoppers randomly selected from a large number of Saturday shoppers, so we have N here is 100, found that the mean shopping spend was €90.45 and the standard deviation of this sample was €20.73. Find a 95% confidence interval for the mean amount spent. So this was what they found the mean to be. So we need to come up with a range of values to be 95% confidence that the mean falls within this range. And to do this, we multiply 1.96 by the standard error of the mean. And the standard error of the mean, you may have seen in other videos, is sigma divided by root n, where sigma is standard deviation. So 1.96 by this is going to give me 1.96 by standard deviation 2073 divided by the square root of 100, which is 10. So we're going to end up with 1.96 by 2.073, which will give me 4.063. So just 4.06, we're dealing with money, not 006. 4.06. So we add this onto our 90.45 and we take it away, and that will give me the 95% confidence interval. So 90.45 plus 4.06 and 90.45 minus 4.06. So that's going to give me 94.51. And this one's going to give me 86.39. So we can say with 95% confidence that the mean, which is mu, is between 94.51 and 86.39. So this is my 95% confidence interval. Part B of this question, a supermarket has claimed that the mean spent by shoppers on Saturday is €94. Based on the survey, test the supermarket's claim using a 5% level of significance. We're testing €94 and clearly state your null hypothesis, your alternative hypothesis, and your conclusion. So we'll take our null hypothesis, H0, we'll take it to be what they've said. The mean is €94. The alternative hypothesis is that the mean is not €94. You could write not equal to as well. So there's a couple of different ways to do this. We could have looked at the confidence interval here. If we use this confidence interval, we can see that €94 is inside that interval. But let's do it using some more maths. Let's look at we're testing against the average and dividing by standard deviation over root n. So we're testing 94. The average was 90.45 from above. My standard deviation was 20.73, was it? 20.73? 20.73. And we're dividing by the square root of 100, or just 10 if you wanted to put 10 in. So typing this into a calculator, we are going to get 1.712, or just 1.71, and as this 1.71 lies within a range, within the range plus or minus 1.96, we fail to reject H0. We could add into that there's not enough evidence to reject null hypothesis. Now we'll look at a diagram just to see this now, and it brings us into part 3. So we look at our 95% confidence interval. 95%. That would mean in the tails here, there's 2.5% in there, and there's 2.5% in there. So for us to reject the null hypothesis, we would have to get a value that falls in here or in here. So now we don't have that. We can see 1.71. This is 1.96 and minus 1.96. So 1.71 is inside here. We could have taken as well. We could have had these two reversed, and we would have got minus 1.71. But either one is fine in this question. This brings us into the tail question in part 3. So part 3, we're asked to find the p-value in the test we performed in part B and explain what it means in the context of the question. So what the p-value is, it's the two tails added together based on our answer, which was 1.71. So we look up 1.71 in the tables, the Z-score tables, we're going to get, so 1.71 gives us a value of 0.9564, which is, this area here will be 1 minus 0.9564, which is 436 would have to be added on, so 0.0436. Now, in the context of this question, we are doing what's called a two-tail test. So the 95% is in here. So the tails add up in this case, if we multiply this by 2, to 872.0872. So this is my p-value, this 0.0872, which is 8.72%. And what this means in the context of the question, the p-value is the probability that the test statistic could occur if the null hypothesis was correct. And the null hypothesis in this case was correct. And we were testing against 90.45. So there'll be either, whatever way we were testing 94, we could have been testing 90.45. Either way around, we would have had minus 1.71 or 1.71. And what this p-value suggests is there's an 8.72% chance of my test statistic being the actual mean.